Dear physics aspirants, right now I have the book of physics and plus 2 level physics will provide you the Newton first law of motion, and the chapter will come under laws of motions. When you study the laws of motions, then you will find this subtopic Newton's laws of motion, Newton's law of motions. It will provide you. I am going to discuss the first law of Newton's law of motion. It will provide you the basic ground full knowledge for your understanding in the physics realms of life. The domain of physics, when you enter, you will get more and more knowledge of the physical world, because physics is very important for ourselves. When you study the physics, then you will be efficient in physically think thoughtful knowledge. You will be efficient. So the basic knowledge we will get under the scientific subject and physics, chemistry, biology, mathematics, and many more subjects is the base of our previous knowledge, which we will get in the cradle of Greece Greece point of view. When you think that, you will find the many more scientific and scientist based knowledge of physics give you the considering power and observation power in yourselves. Here the figure 5.2, a book to rest on the table, and a car moving with uniform velocity. The net force is zero in each case. When you see both the two things, you will initiate the outcome of the Newton's first law of motion, because motion is based on the lifelong processes. When motion, you will see the success is the motion, stability is the unsuccessful mode. So motion, stability, it means when you don't think anything to do the more and more, then you cannot get the success. In general life, motion is very important, that when you are in motion, then you will get the success in future. The aims of the general and specific is very important for any teaching domain. Enter the chapter, I will provide you the information. You will see here the Galileo Galilei 1564 and 1642. Galileo Galilei, born in Pisa, Italy. Pisa, located in Italy in 1564, was a key figure in the scientific revolution in Europe about 4 centuries ago. Galileo proposed the concept of acceleration from experiments on motion of bodies on inclined planes or falling freely in. He contradicted the Aristotelian motion that a force was required to keep a body in motion, and that heavier bodies fall faster than lighter bodies under gravity. He thus arrived at the law of inertia that was the starting point of the subsequent uh, epochal work of Isaac Newton. You will see the figure of Galileo Galilei. You will see the Newton's first law of motion. Galileo's simple but revolutionary ideas dethroned Aristotelian mechanics. A new mechanics had to be developed. This task was accomplished almost single-handedly by Isaac Newton, one of the greatest scientists of all times. Newton's built on Galileo's ideas and laid the foundation of mechanics in terms of 3 laws of motion that go by his name. Galileo's law of inertia was the starting point, which he formulated as the first law of motion. Every body continues to be in its state of rest or the uniform motion in a straight line unless compelled by some external force to act otherwise. The first law of motion, you will see the Galileo's law of inertia was the starting point. You will see here, and the leftovers is here. The state of rest or uniform linear motion both imply zero acceleration. The first law of motion can therefore be simply expressed as if the net External force on a body is zero, its acceleration is zero. Acceleration can be non-zero only if there is a net external force on the body. Two kinds of situations by encountered in the application of this law in practice. In some examples, we know that the net external force on the object is zero. In this case, we can conclude that the acceleration of the object is zero. For example, a spaceship out in interstellar space far from the other object's end, with all its rockets turned off, has no net external force acting on it. Its acceleration, according to the first law, must be zero. If it is in motion, it must continue to move with a uniform velocity. More often, however, we do not know all the forces to begin with. In that case, we know that an object is unaccelerated, i.e. it is either at rest in or in uniform linear motion. We can infer from the first law that the net external force on the object must be zero. Gravity is everywhere. Gravitation law of Newton's gravitation law is the Isaac Newton. For terrestrial phenomena, in particular, every object experiences gravitational force due to their Earth. Also, objects in motion generally experience friction, viscous drag. If then one Earth and object is at rest or in uniform linear motion, it is not because there are two new forces acting on it, but because the various external forces cancel out, i.e. add up to zero net external force. Consider the book at rest on horizontal surface, figure 5.2. You will see here the 5.2, and you can initiate a outcome as a outcome will provide you the better understanding. Here you will see the acting downwards. It is subject to two external forces, the force due to the gravity, I its weight, W acting downwards, and upward forces on the book by the table. The normal force R is the self-adjusting force. This is an example of the kind of situation mentioned above. The forces are not quite known fully, but the state of motion is known. We observe the book to be at rest. Therefore, we conclude from the first law that magnitude of R equals that W. Statement of an encountered is, since W is equal to R, forces cancel, and therefore the book is at rest. This is incorrect reasoning. The correct statement is, since the book is observed to be at rest, the net external force on the it must be zero according to the first law. This implies that the consider normal force R must be equal and opposite to the weight W. Consider the motion of a car starting from rest, picking up speed and then moving on a smooth straight road and with uniform speed. Figure 5.2 will provide you the information. When the car is stationary, there is no net force acting on it. During pickup, it accelerates. This must happen due to net external force. Note, it has to be an external force. The acceleration of the car cannot be accounted for by any internal force. So this might sound surprising, but it is true. The only conceivable external force along the road is the force of friction. It is the functional force and accelerates the car as a whole. You will learn about the friction in section 5.9. It will provide you the better information regarding the friction. When the car moves with constant velocity, there is no net external force. The property of inertia contained in first law is evident in many situations. Suppose we are standing in a stationary bus and the driver starts the bus suddenly. We get thrown backward with a jerk. Why? Our feet are in touch with the floor. If there were no friction, we would remain where we were, while the floor of the bus would simply slip forward under with our feet, and the back of the bus would hit us. However, fortunately, there is some friction between the feet and the floor. If the start is not too certain, i.e. if the acceleration is moderate, the frictional force would be enough to accelerate our feet along with the bus, but our body is not strictly a rigid body. It is indeformable. Does deformable I allows some relative displacement between different parts. What this means, in the while we our feet go with bus and rest of the body it remains where it is due to inertia relative to the bus. Therefore, we are known backward. As soon as that happens, however, the muscular force on the rest of the body by the feet come into play to move the body along with the bus. A similar thing happens when the bus suddenly stops. Our feet stop due to friction, which does not allow relative motion between the feet and the floor of the bus, but the rest of the body continues to move forward due to the inertia. We are thrown forward. The restoring muscular forces again come into play and bring out the body to rest. Here's the example 5.1. You will see, and the answer is here. What is the reason of the question? What is the ground for the answer of the question? You will see here, and you will understand. You will get the information for understanding of the Newton's first law of motion. We will meet in the next video with Newton's second law of motion. It will provide you the laws of motion when you study in physics. Till then, thank you. Thanks for watching the video. Thank you.